to be dropped into the meeting chat. Now you can visit the meeting chat and get the warm-up activity. Good morning, class. Today's lesson is a physics for history. We are going to start unit number 1, which is about qualitative analysis of linear motion. Now, this unit, you see, it is related to the motion, and I hope that everyone is able to define the term motion. The motion, we can say that it's like the changing position from one place to another place. That is simple definition of the motion. Now, after having the definition of this term motion, we can analyze about what is a linear motion and what are the aspects related to this linear motion. Now, students, we have the warm-up activity and we have the link here. I'm going to share you this link and now try to harmonize the activity and see what you know really about this topic before we proceed deeply. Okay, now let me try to share. Okay, to share you this link. Now the link is going to be dropped into the meeting chat. Now you can visit the meeting chat and get the warm-up activity, which can be considered as the activity number 1 for this today's class. Okay, so you have to visit the link and try to do this activity. Everyone can go in the meeting chat and find the link so that you can try to do the activities. So we have 5 minutes to do it. Yes, thank you. Okay, so you can try to define linear motion. Number 2, write 2 types of linear motion. Number 3, what value for acceleration for the above mentioned types. Try to do this question and then yes, thank you very much for your discussion. I see this one is saying that linear motion, for me, I can say that it is in motion where a body moves linearly. Yes, you are right, of course. what I can add is that one. It is the motion whereby a body moves in a straight line. Good. So for question 2, you said types of linear motion, uniform and circular. Yes, one is uniform, but another is non-uniform. Good. For the last, the value of A acceleration is 0 for uniform, good, and any number for circular. It is not for circular, but it is for non-uniform. Good. Now let us continue with our slide to go in deep to understand more about this unit. Good. Now let's come back to our slide. Okay. Yes. Now, after having warm-up activity, now what is a linear motion? We can say a linear motion refers to the movement of an object along a straight path. It's one of the simplest forms of motion you observe every day. Now, we can say after definition, types of linear motion. We have two types of linear motion. One is the uniform, another is non-uniform. So about uniform linear motion, we can say it is a motion in which body moves with constant velocity. Example, a car moving along a straight track, a ball moving along a straight path. These are examples. You can add some more graphs of uniform linear motion. We have different graphs, but for distance time graph, you see it is a straight line, and the speed time graph, we can consider this part A, B, and E, F for horizontal line, because for this case acceleration is 0. Let me repeat, acceleration for this case is 0. Yes, we have the formulas. You can see how to find distance. Distance is a speed times time, or we can find area under the curve of speed time graph. For finding speed is simple. We take distance divide the time, or we can make the slope of a distance time graph. For this case, no need to find out acceleration because acceleration is 0. Non-uniform motion. For non-uniform motion, this is a type of motion in which body moves with varying velocity. Example, a car traveling along a curved path. There are other examples you can mention. The graphs are even here, they are clear. We see that for this, we can say when a body is stationary, which is not moving, the graph is horizontal. If it's moving with constant velocity, for the case of uniform, it's a straight line. When it's increasing or accelerating, it is curved upward, but when it's decreasing, it is curved downward. Now, For the velocity time graph, it is a straight line. Formulas also are there. Acceleration, we take the change in velocity over time, or we can find it by taking the slope of the velocity against the time. Finding distance, simply take average velocity times time. Evaluation now. We are going to do the evaluation. We have the link here. We are going to, I'm going to share it in the meeting chat so that everyone can try to do this quiz and make sure that uh, it is understood. Now, everyone, I think, has signed in. We are going to start our game. So be ready, please. We are going to start our game. Okay. Yeah, bravo, 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 Renata. Now you are the first one on the podium. So you did well, you did your best. I hope now the reason is understood. Thank you very much for your kind attention. See you next time.